Hello, so we have a real analysis problem. Now I know that people ask for calculus. I would argue that calculus is a subset of real analysis. Okay, so let's begin. We have to show that some partial derivative is gonna exist only if these two directional derivatives exist. We're working on this function. So let's begin. Let's start by just, using the definition of partial derivative. Now that's just gonna be the limit t approaches 0, t is not equal to 0, and x0 plus t times ej is supposed to belong to E, since that's where the function is working, that's the domain. And now we'll just apply the expression as typical for this. x0 plus t times aj minus f of x0 over t. And now let's look into the directional ones. First we have the one with direction ej, and thing is, it's gonna be incredibly similar, except the conditions for the limits are not gonna be not equal to 0, but greater than 0. And now let's look into the direction negative ej. Now that's gonna be mild deviation. We will have this replaced, the basics. Minus tj, minus tj. And now, if we were to work with this definition to prove that it exists, we just have to show that this limit exists. For it to exist, we can start by finding the right-hand side limit, the left-hand side limit. Now, the thing is, this is essentially just the right-hand side limit. So now we just need to find the left-hand side limit and say that if they are equal and both exist, then this limit is defined. And what you have here is a very handy limit because we can transform it easily. We can say that we have q equal to negative t, and we can rewrite the limits entirely in terms of q and get one with left-hand side limit. So we have q approaching 0, q is less than 0, and now we just need to replace t everywhere. So here we have plus finally, here we have minus q, here we have plus qaj. And thanks to properties of the limits, we can just bring the minus out. Now let's go back to the original notation of it, and we have this equality where we can just juggle the minus sign on the other side. We got that the right hand side limit for this one is going to be equal to minus directional derivative, where the direction is minus ej. So if both d aj of x0 and minus d minus ej exist and they're equal, then the interior limit is supposed to be defined. Cool, right? Okay, that's it. I mean, we can also perhaps work on this one. I'm not sure how necessary per se that is. I mean, if we were to look at it, we can say that the right-hand side limit is gonna be equal to the general limit, because look at this, it's just this limit, but instead of t not equal to 0, it's t greater than 0, so obviously we can say that the partial derivative is gonna be just equal to this. Okay, we have done this. I spent most of my day just preparing for this, you know, because I lacked foundation on more rigorous multivariable calculus stuff. That's it for today. I hope it wasn't too short for you. Bye.